This lesson gets into transformations of functions, which if you were in Advanced Algebra 2, you have seen these before. If you were in regular Algebra 2, you've seen a couple of these before. All right, so transformations, we're talking about just ways that we can change the shape of the graph. Change the shape, change its location, so a lot of different things that we can do to it. So the transformations are classified as either rigid or non-rigid. Rigid meaning the shape stays the same and the size stays the same, it's just moved around. Okay, whereas non-rigid means it stretches or shrinks the graph. All right, so the first type of transformation, these first four are going to talk about translations, which means just going left, right, up, or down. So these four right here, those are translations. And you add a number at the end. What that's going to do, it's going to go up k units. So if you have f of x plus k, so a number added at the end, it goes up k. Your y, whatever, we would add that k value, that number, to the y. So this, a translation up only affects the y values. F of x minus k goes down k units. So if you subtract on the outside, subtract at the end, it goes down. So again, your x would stay the same. It would be y minus k. And again, it only affects the y. Then we could add or subtract a number, like, you know, when we were in algebra, I said we add or subtract inside. You're adding or subtracting directly to the x. That's going to move it left or right. So if it's x plus a number, it's actually going to go left h units. And this one would be x minus h y. So if you have, and when we get to a real example where you can see it, it's a little different. But if you have like the square root of x plus 3, that means that it's going left 3. And you would subtract a 3 from all of your x values. This one's kind of opposite. Everything's opposite on these two. And those affect your x's. And then this one's the opposite. So if you have x minus 5, that would mean that you go right 5. And so if you go right 5, we're actually going to add 5 to the x coordinate. I know it looks opposite. Okay.
So this is just something that's got to be memorized.
Yes. If you have a calculator, like if it gives you a function, and you're talking about transformations, if you have a calculator, you could type that into the y equals and maybe look at the graph and figure out if it went left or right. Because you should know, like, a quadratic starts on the origin. So if it shifted this way, okay, it went right. You could see that. But who knows, will you have a calculator on this question? I don't know. All right. The next one, the next two, these are reflections. When you have a negative on the outside of a function, that reflects across the x-axis. And so as an ordered pair, if we have a starting point, if we want to reflect it across the x-axis, is my x value changing? If I go, so here's my x-axis, there's my x. If I have this point right here, and I want to reflect it across the x-axis, it's going to go down there. Let's say this is the point 2, 3. What would this point down here be? 2, -3, right? That's a reflection across the x-axis. So the x value doesn't change, the y value became negative. So as an ordered pair, the x value would stay the same, the y would become negative. So this one affected the y value. That's the thing that changed. All right, if you have a negative directly in front of the x, that means it's a reflection across the y-axis, and your x value is what changed. Your y stayed the same. So it affects the x. And now we're getting into the dilations. These tend to be the hardest ones for most people. So dilations, we're looking for a number being multiplied in the front of the function or right in front of the x. So it's a number being multiplied. So here, these numbers, I have an a value being multiplied. It's in the front of the whole function. So a value in front of the whole function, and if that a value is greater than 1. So there's two parts that go with this. If it's an a value in front of the function and is greater than 1, this is a vertical dilation. Or a stretch of, and then we say it's of the absolute value of a. And the reason for that is because if you have this function right here, it looks like the -2 is what's being multiplied by the square root of x. But really, that negative whatever number that is, if we have an ordered pair, that number gets multiplied by the y. that a point. So it's a number between 0 and 1. It's still a vertical, but it's a vertical compression. Or when numbers are multiplied in the very front. When the number is being multiplied directly with the x, so the x kind of on the end. Compression. And in front of my x, I would say it's a horizontal compression of 1 over 2 or 1/2. Okay. And so we do 1 over b times x and then our y. So my x value is what is changed. B, and again 1 over bx y. So the x value is changed. Once we get in, you'll see as we the one and the second one is once we've had some transformations. So I'm starting with the square root of x, and then I get down here. What look at the front. What happens when we add a 3 straight to the x? It would be left. So when you're adding 3 straight to the x, that goes left 3. Okay. What other change do you see? What else is different? There's a negative in the very front. That negative is not exactly with the x. It's kind of in front of everything. So when we have negatives somewhere, those are my reflections. So what do we say when the negative is in the very front? It reflects across the x-axis. Okay. And then there's one other thing that's different. This 3. That 3 is being multiplied by the x plus 3, and that 3 is technically, we would say, kind of on the inside because it's inside of the square root. So what do we have when we multiply a number on the inside? multiplying numbers those are our dilations. The inside would be one of the horizontal ones. Is 3 bigger than 1, or is it between 0 and 1? It's bigger than 1. So that would be, nope, it's going to be the horizontal. See how this B right here is like kind of inside those parentheses? It's considered inside. It would be horizontal compression. To be a vertical dilation, it would look like this. This would be a vertical dilation. See how I moved that 3 to the outside? Here it's on the inside, so it is a horizontal compression.
Why can't it be one of the rigid ones?
Anytime a number is being multiplied, this is the only example that has a number being multiplied. That 3 is being multiplied. The translations up here, these first 4, when I have a number added or subtracted, which was this plus 3, that went with one of those. The 3 being multiplied was a dilation compression. A negative number is always with your reflection. So you'll either have a number being added or subtracted, translation, a negative, reflection, a number being multiplied is one of the dilations. We'll do some more examples, and if we still need some more after this, I'll pull some more up. So horizontal compression of that 3 is considered my B. That's the number being multiplied. So horizontal compression, it's 1 over B. So a horizontal compression of 1/3. So that's what all is happening. We'll keep doing some examples. All right, let's look at number 2. I'm starting with x squared, and I'm going to negative x squared minus 1. What all do you see that's happening here? Okay, we have a negative. This negative is like that. Those are two different things right here. If you have parentheses around the negative x, that would be I would consider that inside. The one that we have, there's no parentheses, so we would consider that one outside. So look at your negatives. Which one has what does a negative outside do? Yes. That one, when you see a negative on the outside, that one reflect across x-axis. What else is happening from my original x squared? Subtracting 1. Now that minus 1 is happening after the x squared, so that would be another considered outside. So what happens when we subtract outside? Down 1. Yep. And it's 1 because it's minus 1. Let's do another one. Number 3, we're starting with 1 over x, and then I have negative 1 over x minus 2. What changes do you see that are being made? There's a negative. That negative, again, is technically on the outside because it's not right with the x. Okay? So a negative outside would be x-axis again, yeah. Reflect across x-axis. And then what else is happening? Subtracting 2. That one is right with the x. Notice it doesn't happen outside or after the fraction. It's right with the x. So when I'm subtracting right with the x, that would be what? Right 2. Good. Let's look at number 4. We're starting with square root of x, and then I'm going to this one. What's happening? There's a negative on the outside. Yep, and the inside. So the outside one is reflection across the what? Reflect across x-axis. There's a negative on the inside. So that one's reflect across the y. And what else is there? There's a what? There's a 1/2. Yes, multiplying by 1/2. So that's going to be one of the dilations, one of the bottom ones. Is that 1/2 on the inside, or is it more on the outside in the front? Inside. Inside. It's still under the square root symbol. So it's going to be one of the B's, the horizontal ones. Notice because that's like inside there. Is 1/2 bigger than 1, or is it between 0 and 1? It's between 0 and 1. So it's going to be a horizontal dilation of, and it's 1 over 1/2. Because my B value is a half. The number that's being multiplied is my B. It's 1/2. So it's 1 over 1/2. That's weird. We don't normally do that. So what is 1 over 1/2? Does anybody know? It is 2. 1 divided by 1/2 is 2. So it's a horizontal dilation of 2. So we're going to keep going. These 5 and 6 are the same, except I'm throwing in a graph there for you. Okay. So let's look at number 5 and decide what all is happening. Yeah. I'm just going to put x-axis because it's easier. What else? Subtracting 2, so that's going to do that. Minus 2 is inside, it's right with the x, so that's going to go right 2, and I'm just going to put R2. And then what? The squared is actually part of the original function, kind of like this one. That's not going to be a transformation. That's kind of telling us it's a parabola shape. Okay. The plus 4, nope, up 4. So when it goes to graphing these, I think maybe the easiest way to do that is to kind of go with a table. In Algebra 2, these are quadratics. The x squared is a parabola shape. This is actually vertex form of a parabola. Where does the vertex sit on a parabola? Just a generic parabola before anything. Where would it normally sit? Just a plain x squared. In the middle, on the origin, right? If we go right 2 and up 4, that's going to move the vertex to what? To 2, 4. Okay. And then unit 5 in the quadratics unit, we looked at this and said, okay, well, the vertex is the opposite of this number and then that number, 2, 4, right? So what we're going to do to graph this, we know that the vertex is 2, 4. I would just go and get a few more points is what I would do. From there, I would kind of make that in my middle, and I got 2 points on either side of that vertex. And you could just plug in a 1 here. So if I do x minus 2, what's 1 minus 2? 1 minus 2. Negative 1. What do I get if I square that? 1. But I have a negative in the front, so that makes it negative 1. Plus 4? 3. Okay. What is 0 minus 2? And I square that, I get 4. Negative 2 times negative 2 is positive 4. But there's a negative in front, so that's going to make it negative 4. Plus 4 is 0. And the cool thing about parabolas is that they are symmetric, so we should also have a 3 and a 0 there. So what this parabola did, your normal parabola, starts out looking like that. So if I were to flip that upside down and then go right to up 4, that's where it would be. So the one in the orange is like just a plain old x squared. So we flipped everything upside down, went right to up 4. Try number 6.